Every day, thousands of fast and very powerful radio signals reach our earthly skies. We don't know where they come from, what causes them, or if aliens are involved. We call them fast radio bursts, or FRBs. And we've had a history of getting anomalous signals from space, and they almost always lead to some new discovery, new kinds of space objects, new phenomena, and sometimes new physics. For instance, in the 1960s, Jocelyn Bell found pulsars. What she was trying to do was to study quasar scintillations using a newly built radio telescope. Coincidentally, what she found were very precise pulses of radio emissions exactly 1.337 seconds apart. And that's a strange signal to find, unlike anything seen before. The first guess was that it must be coming from some sort of interference coming from the environment around the telescope. But it wasn't. It seemed very artificial, a signal that precise coming from space. What would anyone make out of it? Aliens. Yeah, they even called the signal Little Green Man. But later on, a similar signal was found in a completely different region of sky. And so, unless aliens are trying to mess with us, it's probably not them. Sad as it might be. Eventually, this led to the discovery of pulsars, a completely new form of celestial object. They're rapidly spinning neutron stars with high energy beams of radiation coming from their magnetic poles. Their rapid rotation leads to a change in the direction of the beam, which here on Earth register as radio pulses. These neutron stars have a very precise time period, which is why the signal that we were getting was so precise. The big takeaway is that the universe is filled with objects we don't know, or they can do stuff we haven't yet figured out. However, unlike pulsars, FRBs are still largely unknown. We don't know what causes them. They are highly energetic and last for only a couple of milliseconds. They don't always repeat, and even when they do repeat, it's usually quite random, with repetitions ranging from minutes to weeks. They are unlike anything previously seen. For some years after the discovery, no such event was found again, and so people really started to doubt the very existence of these radio bursts until they were observed again. It wasn't a fluke. The universe is filled with these radio bursts coming from all over the universe. Aliens? No, we don't know what exactly causes them, but it is pretty conclusive that it's not aliens, unless of course a huge alien civilization is trying to mess with us. The reason we didn't find them for some time after the discovery is inherent to them being difficult to detect. Given that we only discovered them in 2007, yeah, not exactly easy. If we could detect every FRB that hits Earth, the number would be around 1,000 a day. They come from all over the universe, and not all of them are one-off events as well. A significant number repeats, though quite randomly, as said. Back in the day, it was a lot harder to detect signals of this kind. Radio telescopes had a very low resolution. Pinpointing the location of a detection wasn't really possible. And so we were for a long time completely oblivious to where exactly are these coming from. The way I framed it, does that mean we know them now? Yes, sort of. Nowadays, by using interferometry or by using multiple radio telescopes, we get a far better idea of the region in the sky where a signal has come. This is exactly the same technique as used by the Event Horizon telescope to image the black hole in the center of our galaxy and in the galaxy Imager 7. The Event Horizon telescope is nothing but a group of 11 now telescopes spread across the entire planet, mimicking the effect of a planet-sized telescope, giving it a far better resolution. Ingenious. Recently, the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, had been a real breakthrough in detecting FRBs. The reason being, its cylindrical dish, which gives it a far bigger field of view. It points right upwards, and as the Earth rotates, it scans all of the accessible sky every 24 hours, detecting far more FRBs than we have done ever before. And then by using other telescopes like the VLBA, which is also nothing but a group of telescopes, we can locate where the signal has come. For context of how big of a breakthrough CHIME was, from 2007 to 2017, we detected around 30-ish FRBs. In its very first year of operation, CHIME found 536. Wow. So does that mean we know what causes these FRBs? No. The thing is, we've found repeating FRBs, non-repeating FRBs, FRBs coming from dwarf galaxies, but also active ones. Also from a location with half a dozen interacting galaxies. FRBs that are a fraction of a millisecond long, but also complex ones that are a couple of seconds long. So now that we are oblivious again, there's one big hint in the name itself. These are fast radio bursts. they last for only milliseconds, which kinda puts a limit to how big the original source could be. A very rough calculation shows roughly hundreds of kilometers, which means the source must be a very compact object. Something like a neutron star or a black hole could power these events. The most popular explanation is a magnetar. A magnetar is a neutron star with a significantly stronger magnetic field, thousands of times stronger than a standard neutron star. The idea is similar to solar flares. These magnetars go through violent rearrangements of their magnetic field, leading to magnetic flares that pushes electrons or other charged particles out, giving rise to radio bursts. The exact mechanism is still quite unknown, but a fair few of these FRBs have been found to be associated with known locations of magnetar. But can magnetars account for all the FRBs? Remember the multitude of places we've found FRBs? Some of these certainly do come from magnetars, but all seem unlikely, which means there is probably not one single way these FRBs form. Mergers are one other way these bursts may happen. The fact that some of these FRBs also repeat means that they do develop a sort of condition where energy builds up only to be released in a very short time. And so all the explanations involving merger are then certain to not be the only way, since they can't keep merging repeatedly, right? FRBs have been quite useful in shining light to this otherwise dark universe. These radio pulses travel the entire distance before reaching us, and hence they encode the fingerprints of the stuff they encountered. Light gets dispersed in a medium. The universe seems quite empty, but on such large length scales, even the smallest of densities start to have their influence. And the universe is never truly empty. There's always something, some sort of a medium. The different wavelengths of these FRBs gets dispersed to different amounts, leading to a dispersion spread that contains information of how much and what kind of matter is present in between. It's interesting how much we've known about the universe because of these FRBs, and yet so much to know about what causes them. With more data, we will eventually be more confident with the sources of these FRBs. A fair few of them have been linked with magnetars, but we haven't closed the case. Till then, wonder what strange phenomena might be causing the rest of them. Thanks for watching.